All right, 10.6 segment relationships in chords. So starting off with this theorem here, if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. Right? So if we start off with this chord that would have like a positive slope here, DE times EC equals AE times EB. All right, so here we are, example 20, find JK and LM. And what we're going to do, we're just going to solve for X here. We're not going to find the lengths there. So first we have JK splits into these two pieces, so I can have X plus 7, and we multiply them together. Then the other one would be X plus 2, X plus 3. Distributing this out, I'd have X squared plus 7X plus X squared plus 5X plus 6. Solving this, I'd have 7X equals 5X plus 6, 2X is 6, and X is 3. All right, scrolling down. A tangent segment is a segment that is tangent to the circle at an endpoint. A secant segment is a segment that contains a chord of the circle, right? A tangent, we've always thought of a tangent as being touching the edge of the circle and continuing. This one is a tangent segment. It's cutting off the line, right? It's just this piece of it. Same thing with a secant. A secant normally goes through a circle. Well, now we're only thinking of a part of it that goes through the circle. We have the external segment, that's the piece that's outside, and the secant segment, the part that's inside. Next up, if two secant segments share the same endpoint outside the circle, so that we're talking about point E there. Hey, Pepper. There. Now you can't see out the window. All right, back to math. Here we'll do the outside times the whole. That's the way that I remember that. So here we have on the left side, it's all in words, and then here we have it on the right side in math, but this is the little shorthand that I remember. We have EA times EB, that's the whole, so we have the outside times the whole, and then for the other one we have, again, EC, which is the outside, and then ED, which is the whole. So we can remember that that's just the outside times the whole thing. Example 21, we're supposed to find X. Well, the outside, we'll look at this top one, HF first. The outside is 4. The whole thing is 4 plus X. For the bottom one, the outside is 6, and the whole thing is 6 plus 18, which would be 24. Solving this, I'm going to start off by doing 6 times 24 on the right. That gives me 144. And then I'm going to divide by 4. And I subtract my 4, and I have X equals 32. All right, next up. Segments of secants. So here we have, on the left side, you have all those words, and you can read that if you'd like, but I'm going to more refer to the diagram. It still follows the same rule, outside times the whole. EA, right here, is outside, and it's also the whole. So it's just going to be EA squared. And then for the other one, for the actual secant segment, it follows the same rule, outside times the whole thing. So example 22, find VW. Okay, so that's the same thing as saying find X, because X is VW. Well, the top thing is 18, that's the outside, and the whole thing is also 18. For the other one, we have X is on the outside, and the whole thing would be X plus 27. Now multiplying this together, 18 times 18 is 324 equals X squared plus 27X. Now this one turns into a quadratic, which is going to be a little bit harder to solve. So we'll have 0 equals X squared plus 27X plus 324. And now we need to find numbers that multiply to be 324 that add up to be 27. What is 9 and 36? 9 times 36 is 324, and 36 minus 9 is 27, but that won't work for us because they're both positive. Oh no, this is supposed to be negative here. Pepper, outside later. So we can simplify, or we can break this apart to be 0 equals X minus 9, X plus 36. So 0 equals X minus 9, and 0 equals X plus 36. And then X equals 9, X equals negative 36. It does not make sense to have a negative length, so we're not going to we're not going to use the negative 36. Our answer is just going to be the positive 9. All right? There will be some problems like this on the homework where you have quadratic and you have to break it apart. Remember, you multiply to be the last piece, and you add up to be the middle piece, right? If there's a coefficient, if there's something in front of your x squared term, then you either need to divide by it or you need to just use another method, like the quadratic formula. There's ways that you can factor it if that's not a 1, if there's a number there, but it just gets way harder. So that would be my suggestion, would be to use the quadratic formula, or say that all 3 terms are even, then you could divide by 2 there too. But yeah, make sure we have that. Make sure we know the outside times the whole thing. That's a very important formula there. And then we have the one for the inside where you multiply each piece of it. So, all right, that's all.